All right, so 2 out of these 3 words we already know. You guys have already talked about theorem and postulate. So our goal today is going to be to prove theorems about line segments and angles. So this new word, proof. Okay? And I've talked about it a little bit when we talked about that because we said that a theorem is a rule or a conjecture that needs to be proven, and that's how we defined it before. And now we're going to actually talk about how we are going to prove these theorems. So a proof has to be a logical argument, has to use definitions and rules that we already know. So it uses a series of statements and reasons to prove a conjecture or theorem. Okay, so it's an argument with a series of statements and reasons to prove a conjecture or theorem. Okay, so like I said, those statements and reasons have to be any kind of definitions that we already know. It can be postulates that we already know, because postulates, that's a rule or a conjecture that's obviously true, that we don't have to sit there and argue about because we know that it's true. That's kind of like any 2 points form a line. Remember that postulate that we did? If you draw 2 points anywhere, you can always take a straight edge and connect it with a line. You might need a longer straight edge, but you can always connect those 2 points, form a line. So postulates are obviously true. So we can use postulates when we're proving. We can use definitions. We can use theorems that we've already proven. Okay? All of those are things that we can use when we go to do a proof. So, prove the common segments theorem. If A, B, C, and D are collinear, as shown in the figure, with AB equal to CD, so the distance between A and B is equal to the distance between C and D, then the distance between A and C must be the same as the distance between B and D. Okay, so we can kind of look at that and see, yeah, that looks right. But we actually need to prove this because it's a theorem. So as soon as you see the word theorem there, that means we have to prove it. So our given is the hypothesis of our statement. So now you think back and say, oh, I thought we were just talking in sentences like, if someone brings Mrs. Fox a Snickers, then she will be happy. And I like that stuff because we didn't have to talk about math. But when we were doing that, we were talking about conditional statements. Now we're going to use conditional statements and relate it to math. So I told you we were going to simplify this idea of conditional statements, converses, and biconditionals to things that we're more familiar with. Now we're going to work at applying it to the geometry part. Okay? So the given is your if part. That's your hypothesis. The prove is going to be your then part or your conclusion from the conditional statement. Most theorems are all going to be written or can be written as a conditional statement, an if-then statement. Okay? So the big idea that we're given is that AB is equal to CD. Anything that comes from this diagram is also a given. So when we go to write our reason for our statement, that will be given. Okay? I am not having you do any proofs on your own yet this unit. So yes, we are proving a couple proofs or theorems together. You will not be expected to do this on your test next week. Something that you'd be expected to do on your test are more like the section 4 examples. Does that make sense? Okay. All right, so we're given that AB is equal to CD. We have to prove that AC is equal to BD. That's the conclusion part. So our very first statement is always going to be the given. So AB equals CD. Given is my reason. Whatever you're given, that always is going to be. Your reason is your given. Your statement is the very first given. Okay. Looking at this, I know that I'm going to be adding this middle segment to both sides. So BC is equal to itself. Okay, so that's the reflexive property of equality. Since I know BC is equal to itself, that means I can add it to both sides of this equation. Okay, so from 1, I can add BC on the left side, and I can take CD and add BC to it on the right side. Okay. If I added BC to both sides, what is my reason here? If I added a segment to both sides, yes, the addition property of equality. I added the same thing to both sides of the equation, and that's what I have. Okay, so let's look at this. AB plus BC. AB plus BC, that equals a larger segment. What does it equal? Doesn't equal AD, doesn't equal the whole thing. AB plus BC equals what? AC. Okay. Similarly, if I add CD and BC together, CD and BC together, what segment does that equal when I add this far right one and the middle one together? BD. Right? Is that okay? Why is that? Why is it if I add these two segments, it equals this whole segment, and if I add these two segments, it equals this whole segment? What's my rule that tells me I can add two parts together and it equals the whole thing with segments? The segment addition postulate. Okay. Now, I said that this AB plus BC is equal to AC. So I'm going to replace the left side of that equation with AC equals the right side of that equation I said was equal to BD. So I'm going to replace that with BD. I knew that this had to be my very last statement because that's what I'm trying to prove. But why was I allowed to replace the left side with AC and the right side with BD? Substitution. Yes. Because you're substituting AC in for that expression. It comes here. You're going to substitute BD in for that expression. It comes here. So substitution allows you to do that. The substitution property of equality. Okay. And now we have another, like, 4 theorems, and we're going to talk about them, but we're going to do a lot of writing, and then we'll talk. Okie doke. So, the first one says if two angles are supplementary. Oops. To the same angle, then the two angles must be congruent. The congruent complements theorem is very similar to that and says if two angles are complementary, to the same angle, then the two angles must be congruent. The right angles theorem says all right angles are congruent. And there's another congruent supplements theorem, and it says if two angles are congruent and supplementary, then they are right angles. So I'll give you a minute to catch up with writing. All right. So what does the word supplementary mean? Because that's the big idea here. We have lots of times we've used this word. Supplementary. What does it mean if two angles are supplementary? They have to add to 180. Okay. My biggest pet peeve is that people say equals 180. They don't equal 180 because that basically says that each angle equals 180. You have to say that word, they add to 180 in there. Okay? So two angles are supplementary. That means those two angles add to 180. So if two angles are supplementary to the same angle, I would have two angles and this third angle, this new angle. Both of these angles, their supplementary angle that make them add to 180 is the exact same angle. Okay? So let's say I had these two angles and the angle that's supplementary is 30 degrees. What do those two angles have to have a measure of if they're both supplementary to a 30-degree angle? They're both 150 degrees. And if those angles have the same measure, they have to have the same measure because there's only one number that's going to get it to 180. Those two angles have to have the same measure. That means that they must be congruent to each other. Because when two angles have the same measure, that's what makes angles congruent. It's kind of like being equal, but we use the word congruent when we're talking about figures. Does that make sense? Are we okay with that idea? Yes?
So, like, the third angle is like the missing piece of the...
Yeah, kind of. The third angle is kind of like the missing piece, yeah. Okay, so two angles are supplementary to the same angle. Then those original two angles must be congruent. Okay? Now, what does complementary mean? They add up to what? 90. They have to add up to 90 degrees. Okay, so we have two angles that are complementary to the same angle. So what if that angle, we have two angles here, and they're complementary to, let's say, this 20-degree angle. What do both of these angles have to have a measure of if they're complementary with a 20-degree angle? They both have to have a measure of 70 degrees. If both of these angles have a measure of 70 degrees, these two angles are congruent. Does that make sense? So it's the exact same idea. It's just the one word that's changed there is supplementary to complementary, but it's adding up to a specific number. So if you have a number it has to add to, then, and you already have a set number, there's only one option for that other angle to be. And we're not going to prove these theorems, at least not today. Maybe at one point we'll come back and prove them, but we're not going to prove them today. The right angle theorem just says that all angles are congruent. What does a right angle have a measure of? 90. That's all this proof really much explains, is that if you have a right angle and you have another right angle, the measure of this angle is going to be 90. The measure of this angle is 90. The measure of 90 is equal to the measure of 90, which means that the angles then have to be congruent. And you could say that for any right angle. Does that make sense? So all right angles are congruent. Most people don't even remember the name to this. They just write in a reason, all right angles congruent. Right angles congruent. It doesn't matter. I'm not going to be picky about memorizing these names. As long as you understand these theorems, that's fine. Okay. Congruent supplements theorem says if two angles are congruent and supplementary. So they have to have the same measure. And what does supplementary mean? They have to add up to 180. So if they have to have the same measure and add up to 180, what are your only options for the angles? If they have to be the same, and when you add them, you get 180, what are your only numbers that work? 90 and 90. Add to 180, and they're the same. If you tried 80 and 80, it's not going to add to 180, right? You add 60 and 60, it's not going to add to 180. The only way you'll have the same angle, and you add them together and get to 180, is if they're 90 and 90. So that means if it's a 90-degree angle, what kind of angle is it? A right angle. So it just says that if they are congruent and supplementary, then they must be right angles. Is that okay of an idea? All right. Let's flip it over then. All right, so a linear pair, you guys worked on this on your assignment the other day to define a linear pair. And we've recognized linear pairs. We haven't actually written a proper definition. The proper definition of a linear pair, if you open up a geometry book, is a pair of adjacent angles whose non-common sides are opposite rays. That's the actual definition of a linear pair. Most people use the linear pair theorem as their definition of a linear pair because it's easier to visualize. Okay? I will not make you memorize the definition of a linear pair, but you do have to know when you're using the linear pair theorem versus a linear pair definition. If you're stating that two angles form a linear pair, that's using the definition. Okay? If you're saying that a linear pair has a specific characteristic, you're probably using a theorem. Okay? More than just that they have opposite rays. So let's draw what a linear pair then looks like. A pair of adjacent angles, meaning that they have to have a common ray, okay? And their non-common ray are opposite rays. Do you remember what opposite rays mean? It means that they form a line. Okay, so they're all on the same line. They form a line. They go in opposite directions. So this would be angle 1, that would be angle 2. 1 and 2 are a linear pair. That's the proper definition of a linear pair. A pair of adjacent angles, they have to share a ray, that common ray in the middle, whose non-common sides are opposite rays. So these form a line. Okay. The linear pair theorem says that if two angles form a linear pair, then they are supplementary. Okay. Most of you tried to define a linear pair as adjacent and supplementary. That's true. Those are true about a linear pair, but that's because of the linear pair theorem. So we are going to prove the linear pair theorem, so now you can actually start using the linear pair theorem, which states that if they form a linear pair, then they are supplementary. So what we are given here is, remember, the if part of our statement. Okay? So let's call this angle 1, and we'll call this angle 2. And you can do that where you can label them in your diagram like that. It might be a little bit easier to name that way. So we'll say that angle 1 and angle 2. Now we're using that law of detachment because we're being specific to our diagram here. It says if two angles form a linear pair, we're going to name our angles. Angle 1 and 2 form a linear pair. Now, we often abbreviate linear pair as LP. If you use LP, I know you're referring to a linear pair. Okay? That is an okay abbreviation to use. Just like POE is an okay abbreviation to use. Okay? To prove the linear pair theorem, our given is angle 1 and angle 2 form a linear pair. Our prove has to be that then they are supplementary. So we're going to try to prove that angle 1 and angle 2 are supplementary. Okay. I know the very first thing in my proof, my very first statement is going to be my given. That will be my reason, and I'm going to write down my given as a statement. Angle 1 and angle 2 form an LP. Okay, 1 and 2 are a linear pair. I can tell already that my very last statement is going to be what I'm trying to prove, that angle 1 and angle 2 are supplementary. I don't know my reason until I find out what 6 is and how did I get to 7. Okay, so I cannot fill in my reason. But there's 3 points that you'll always be able to get on your proof just from the given and the proof. Okay, the given and the proof will always be given to you if you're asked to do it on your own. Okay. So, one thing that I know from this is since 1 and 2 are a linear pair, that means that these two rays are opposite rays. So ray JL and ray JK are opposite rays. And I know that because since it says that those are a linear pair, the definition says that those are opposite rays. So that's the definition of a linear pair that tells me that they form opposite rays. Okay. If 2 rays are opposite rays, then I know that what do they form? What do they form? If they're opposite rays, what do they form? What's the definition of opposite rays? They form a line. So the definition of opposite rays says that JL, ray JL and ray JK form a line. Since they form a line, I know that the measure of angle LJK, what would be the measure of LJK, that angle? What's the measure of this whole angle? LJK. 180. Okay. I know that because since they form a line, what kind of angle is that? No, not supplementary. That would be what the 2 angles add to. But what do we call an angle that is 180 degrees? I think I heard it. Not a line. Something angle. A straight angle. Okay? So that's the definition of a straight angle. A straight angle says that if they form opposite rays and they form a line, then that's a straight angle. And we know by the definition of a straight angle that it forms a line and the measure is 180 degrees. Okay, so that's how I know that that measure is 180 degrees. I also know that the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle LJK. Why do I know that 1 and 2 add to LJK? Why do I know that this part plus this part equals the whole thing? What's my reasoning there? What tells me that when I add 2 angles together, it equals the whole thing? The angle addition postulate. The angle addition postulate tells me part plus part equals whole of the angles. So angle 1 plus angle 2 equals the whole angle, which is the measure of LJK. All right. Well, LJK and measure of LJK, what does the measure of angle LJK equal? 180. So let's replace it right here with 180. So what I have then is that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. What did I do to replace the measure of LJK with 180? Substitution. Property of equality. When you substitute, it's not going to change the equality at all. Okay? So then my very last statement says that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That means angle 1 and angle 2 are supplementary. Why is it that if you add these 2 angles and they add up to 180, that they are supplementary? The definition of supplementary. Very good. The definition of supplementary says that if two angles add to 180 degrees, then they are supplementary. Or if two angles are supplementary, then they add to 180 degrees. Or since that's a really good definition, we could write it as a biconditional and say two angles that add to 180 degrees if and only if they are supplementary. Two angles add to 180 degrees if and only if they are supplementary. That's how we'd write it. Right? That's why we learned about those good definitions. Okay? We practiced them. All right. So we proved the linear pair theorem. So now anytime you see a linear pair, you could say that they are a linear pair, and then you could say they are supplementary because of the linear pair theorem. If you state that they are a linear pair, then you can go right to saying they are supplementary because they are a linear pair, because of the linear pair theorem. Okay? So the linear pair theorem is something you will have to memorize. You have to know what the linear pair theorem is. I'm going to ask you to state the linear pair theorem on your test next week. And you're going to have to come up with, if two angles form a linear pair, then they are supplementary. Okay. I'm also going to ask you to state the vertical angles theorem on your test next week. And the vertical angles theorem says if two angles are vertical angles, then they have equal measures. Or you could say then they are congruent. I don't care. They're very, very close. Okay. So if two angles are vertical angles, give me two angles here that are vertical angles so that I can write it as my given. 1 and 3 work. So angle 1 and angle 3 are vertical angles. We abbreviate vertical angles as VA. That is an appropriate abbreviation for geometry class. Vertical angles is going to be VA. It will be that for the whole year. We will come back to vertical angles every single unit. Linear pairs and vertical angles are probably the biggest idea in geometry because it's something we come back to almost daily in geometry. Now that we have a good understanding of them and we know these theorems, we will use them all the time. Okay? So our given is the if part. If two angles are vertical angles, we use that law of detachment. We specify it to this diagram. Angle 1 and angle 3 are vertical angles. Then they have equal measures. So then I'm going to say angle 1, or I can say the measure of angle 1. They have equal measures. So the measure of angle 1 equals the measure of angle 3. Okay. There we go. That's my given. That's my proof. I can go in and fill in my boxes that I know. So my first given is angle 1 and angle 3 are vertical angles. I know that my reason is given. I know my very last statement is going to be what it is I'm trying to prove. So I can fill all those boxes in right away. I don't know my last reason because I don't know what step 5 is yet. I have to figure out how did I get from 5 to 6 before I can fill out my reasoning for 6. Okay, so you can only fill out those 3 boxes. So, angle 1 and angle 3 are vertical angles. That is given. I know that angles 1 and 2 are a linear pair. I also know that angles 2 and angle 3 are a linear pair. And you may recognize this because we actually talked about the vertical angles theorem back in Unit 1. We did talk briefly about it. We did not discuss it as the vertical angles theorem, but we did discuss that vertical angles were congruent. Now we're going to have reasoning behind it. We discussed this proof in verbal conversation of how it works. 1 and 2 are a linear pair, and 2 and 3 are a linear pair. How do I know that 1 and 2 are a linear pair? How do I know that something is that definition or that description? You can identify something as a specific term because of its definition. So if I say that they are linear pairs, what am I using to say that they're a linear pair? The definition of a linear pair. If I say that two things are a vertical angle, I'm going to use the definition of a vertical angle to say that. If I say that two angles are adjacent, it's because I'm using the definition of adjacent angles. I'm identifying something as a certain vocabulary word based on its definition. It follows the definition. So this is because of the definition of a linear pair. I can see it. You can see it, then what you're stating is, I can see it follows the definition, and you know it's a linear pair. Okay? So, if angles 1 and 2 are a linear pair, what else do you know about them? What is the proper term there, though? They are supplementary, yes. So I also know that angle 1 and angle 2 are supplementary. I also know that angle 2 and angle 3 are supplementary. What says if two angles form a linear pair, then they are supplementary? Yes, the linear pair theorem, that part we just proved, said that if two angles form a linear pair, then they must be supplementary. So the linear pair theorem allows us to say that. Okay, well, if 1 and 2 are supplementary, then I know that the measure of angle 1 plus the measure of angle 2 equals 180. How come? Why, if they're supplementary, do they add to 180? What tells you if something's supplementary, then it must add to 180? The definition of supplementary. And I also know that 2 and 3 are supplementary, so the measure of angle 2 plus the measure of angle 3 has to also equal 180. Okay. This is not the only option for this proof. This is just how we're going through and proving it. Okay, well, if 180 and 180 are in both of these, then I could set those equal to each other. I could replace this 180 with that 180, which is this. So I could say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. If they're both equal to 180, that means these are both equal. If blue equals red and red equals green, then green must equal blue. What rule did you use that says if this equals that and that equals this, then this has to equal that? Transitive property, yeah. You could also use substitution here, but I think it looks more transitive to me. Okay. I recognize it as transitive, but yes, it is also substitution. You're just substituting the measure of angle 2 and plus the measure of angle 3 in for 180. So either one would work. I recognize it as transitive. That was my first initial. I look at it. This goes to that. That goes to this. Transitive. But yes, it's also substitution. I don't care which one you choose. All right. Well, then from 5, how did we get to 6? Somehow I changed the equation in 5 and got to 6. I didn't simplify it. I didn't combine like terms. That's what simplifying is. What did I do? What did I do? No, it's not the angle addition. That would be part plus part equals whole. Look at what I have here. I have the measure of angle 1 plus the measure of angle 2. It turns into just 1. Over here I have 2 and 3, and it turns into just 3. What happened? You subtract the measure of angle 2 from both sides. If you subtract the measure of angle 2 from both sides, it goes away on both sides, and you're left with that. So my reasoning is what? What's my reasoning if I subtracted the measure of angle 2 on both sides? Subtraction what? Yes, subtraction property of equality. Okay. So, big things here. Vertical angles theorem, linear pair theorem. We have to make sure we memorize those two theorems. You will never have to prove them again. We proved them as class. Okay? In order to use a theorem, you're supposed to prove it. That's why we proved it as a class. These are our two theorems that we're going to use the most often. All right? The next page is the assignment. And if you look at it, there are proofs on there, but really it's going through the steps, and then you have to come up with the reasons. Okay? Here, this one tells you the reason is substitution. So you're going to want to look and say, what could you substitute AC as if AC equals AB plus BC? So you're going to have to use some substitution to come up with 3. Okay? And then look and see what is number 1? What's the reason for number 1 always? Given. When you're doing a proof, the first reason, as long as it matches with your given, AC equals BD, cool, it's given. Sometimes people will spend, if there's like 2 givens, sometimes people will write the first one as your first statement, and then they'll do a couple things, and then like halfway down, they'll put that other given in there. So sometimes you'll have a second given, but you'll always have to start with your given. Okay? And so you want to look and say, okay, if that's given, how did I come up with this 2 statement? Did 1 change into 2, or was 2 a new idea? And then you have to come up with your reason. All right? You have the rest of the time to work.